All right, so today we're going to do 2-digit by 1-digit multiplication. 2-digit by 1-digit multiplication. Here's our sample problem. Mary Ann bought 3 packages of cookies. Each box contained 12 cookies. How many cookies did Mary Ann buy? So if I set up my window pane, what I'm looking for is how many cookies buy. I want to know how many cookies Mary bought. The first piece of information that I'm looking at is the 3 packages of cookies. So when I draw my unit bar, I draw my 3 packages of cookies. Each of those packages contain 12 cookies. So inside each of those boxes, I'm going to put a 12. And I'm looking for my total. I'm looking for how many cookies that is. Now, if you're really good with your fast facts, you already know what 3 times 12 is. But I'm using this as an example. Okay? So my multiplication problem is 3 times 12. So let me rewrite that for the way that we're doing 2-digit by 1-digit. 3 times 12. Now, when I do 3 times 12, I'm going to erase this for now so that way I've got enough room. I can show this in a couple of different ways. First is a picture. 12 is 1 10 and 2 ones. Well, I've got 3 of those. Okay? And just like whenever I'm adding or I'm doing anything where I'm combining my base 10 rods and units, I've got to try and make tens. So here I have 1, 2, 3, 4, 5, 6. So I've only got 6 ones, not enough to make a 10. Okay, so I'm going to look at my tens. 1, 2, 3. I only have 3 of them. So my product should be 36. Okay? That's looking at it as a picture. However, when we get into larger problems, it's not going to be as nice and fun to try and draw pictures. I don't want to draw 8 12s or 8 12s. That's a lot. It's going to take me a long time, and really it's going to waste a lot of time. So let me show you what 12 times 3 means. So we did it as a picture. But 12 times 3, 12 is really 10 plus 2. So really what I'm doing is I'm multiplying 3 times 2 and 3 times 10. Well, those are easy enough problems to solve. 3 times 2 is 6, and 3 times 10 is 30. When I add them up, I get 36. Just the way that we have down there. Again, nothing wrong with this method, but it's still taking me a little bit too long. I'm still having to do extra steps. But this is one way. This is one way of solving it as well. There's a second way of solving it, excuse me. The last way is the way that I'm hoping that everyone gets to. This is the way that I want everyone to eventually start solving problems. Start solving these types of problems. And it's to use an algorithm. Now, an algorithm sounds like a big, scary word, but it's not. What an algorithm is it's just a procedure. It's a process. It's the steps that I'm going to take to solve it. So it's nothing scary. First thing I'm going to do is I'm going to multiply 3 times 2. And that equals 6. I write my product there. If I equaled something larger, I would have to carry my 1, just the way that I do in addition. Just like addition. Okay? My second step, let's go to diagonal, multiply 3 times 1. 3 times 1 is 3. Again, if there was another number up there, then I would add it. I would multiply 3 times 1 and then add whatever number else was up here. But there's not one, so it's just 36. Okay. Let's take a look at another one. Bethany babysat for 5 days. She earned $23 each day she babysat. How much did she earn? So again, I'm looking for how much did she earn? When I draw my picture, I'm going to draw 5 days. And what these dots mean right here in the middle, is that the same thing is happening over and over and over again. So it's 23, 23, 23, 23, all 5 23s. Okay. And lastly, I need to know how much is it all together. Here's my total, here's my each, here's my groups. Again, I'm going to multiply 23 times 5. Let me erase this so I've got enough room. I'm going to show you using the picture using all 3 methods again, but the first thing I'm going to do is show you the picture method. 23, 2 10s, 3 1s. And since I'm on the smartboard, I can kind of cheat and clone it a couple of times. 1 2 3 4 and 5. I've got 5 of them. Draw a line kind of separating. Okay. And as we said before, we need to make groups. I'm trying to make groups of 10. So 1 2 3 4 5 6 7 8 9 10. Okay. Make my 10 here. And when I make a 10, I have to regroup that 10 as a 10. So instead of having 10 ones, I'm trading it in for another one right there. And, we'll scratch through that so that way it looks like they don't exist anymore. Okay. And then what's left is I've got 1 2 3 4 5 ones. Okay. Next, I've got to regroup my 10s. I've got 1 2 3 4 5 6 7 8 9 10. I have 10 10s. I can trade those 10 10s in for 100. There's my 100. Again, I'll scratch through these. So we're getting rid of those. And how many do I have left? I've got 1 10 left. And lastly, now I count my hundreds. How many hundreds do I have? I've got 1 100. So my product should equal 115. And we're going to double check that here in 1 second. Just going to move this down. Okay. Oh, made it a little bit smaller. Oh well. Alright. Let's take 23, which is really 20 plus 3, and we're multiplying it times 5. So it's like saying 5 times 3 and 5 times 20. 5 times 3 equals 6. 5 times 20, well, I've got my 5, I've got my 2. 5 times 2 is 10. Take my 0, add it back over here, equals 100. 5 times 20 equals 100. Add them together, 6, 0, and 1. Oh, I know what I did wrong. Shouldn't equal 6. I don't know what I was thinking. 5 times 3 equals 15. Y'all are probably screaming at me. Sorry about that. 5, 1, and 1. 115. So you can see, because I did this down here, I was able to check. So I'll check my work and tell that, hey, I made a mistake. That's all right. Everyone makes mistakes, even teachers. All right, lastly, the way I hope you guys solve it is by multiplying 23 times 5. My first step is to multiply 5 times 3, and that equals 15. Here I write my 5, and I carry my 1. Okay. Second thing I do is I multiply 5 times 2, and that equals 10. But wait, I've got a 1 up there. So I have to add that 1 to it, and it equals 11. So my product equals 115.